Number 2A asks to approximate the area using a midpoint Riemann sum. They don't give us a table this time, but they do give us an equation. So whenever we don't have a table, you want to set up a table. I think that's the best way to go because using a table is the easiest, I think, when you're approximating area like this. So let's go ahead and make a table. And we're going to have, let me make that a little bit bigger. But we're going to have x values and we're going to have f of x values. So we're going to have two-sided table. We're going to have x, we're going to have f of x. There we go. A little bit better. So, but we don't know where to start. That's where this definite integral comes in down here. So they tell us that we're looking from 1 to 7. So let's write all of those numbers in. We have 1, 2, 3, 4, 5, 6, and 7. To get the f of x values, we need to plug in these x values to our equation up here. So 1 squared is 1, minus 5 is negative 4. And then I went through and I went ahead and calculated these all out. So if you're working along with this video, take a minute to make sure that you can plug in these numbers and get them accurately. And then, so press pause, do that, and then press play and check your work. So then we have negative 1, 4, 11, 20, 31, and 44. So what it has asked us to do in this problem is it's asked us for a midpoint Riemann sum. So remember, this isn't going to be left or right. We're looking for the midpoint. And they said 2 subintervals of equal length. So if we're looking from 1 to 7, that means our entire interval is 6 units long. If they want 2 subintervals, that means we need to divide this up into 2 intervals, which means that our subintervals, our rectangles, are going to be 3 units long. So we're going to have a rectangle from 1, 2, 3, 4. That will be 3 units. And then from 4 to 5 to 6 to 7, that will be 3 units. So here's our 1, and here's our 2. Okay, so we need the midpoint of these. So we need to look in the middle. So the midpoint is actually right in between 2 and 3 here, and right in between 5 and 6 here. So we actually didn't put enough information on our table, but that's fine because we got the table, we made the table, so we can add values to that table. So what we need to add halfway in between 2 and 3, we need to add 2.5. We need to figure out what that y value is. So we're going to add a value there, and halfway in between 5 and 6, so we need to add 5.5 to get the y value there, because that will be the height of these 2 rectangles. The base, we already know that both of these rectangles have a base of 3. So R1 has a base of 3, and R2 has a base of 3. So, move these over a little bit. We're going to take these numbers and we're going to take 2.5 and plug it into our equation. So we'll have 2.5 squared minus 5. When you do that, you get 1.25. And then we plug in 5.5 up here. So 5.5 squared minus 5 is 25.25. So here, my height is 1.25. And here, my height is 25.25. So I multiply both of those by 3. So I have 3.75 plus 75.75. And I add those together, I get a total of 79.5 units squared is my midpoint approximation here.